Okay, finishing up lesson 3, you're looking at this example and you're saying, this looks pretty familiar. The only difference here now, you'll notice that we've gone to a 3D system here, so x, y, and z. So now the points are three-dimensional. So does the process change? Absolutely not. So to find vector QP, you simply do point P minus point Q, keeping in mind that point P is still a coordinate, so use round brackets. And Q is the 315. When you subtract 2 points, the result is a vector. So we end up with the vector 6. -1 take away 1 is -2. And 4 take away 5 is -1. So there we go. That is vector QP when you're given the points. Determining magnitude. Magnitude, same thing. Maintain those magnitude symbols all the way through. So we're taking point P, subtract point R, so 3, -1, 4, and we're going to subtract -7, -4, -2. Oops, just should have been an absolute value symbol. You'll know that you find that the notation becomes a little bit frustrating after a while until you get real comfortable with it. So we end up with 10. We're adding 4 to that, so that'll be a 3. And adding 2, so that becomes a 6. And we then switch to the actual magnitude at this point. So it'll be the square root of your x component squared plus your y component squared plus your z component squared. 109 and 36. So the square root of 145 units. So there you go. That's the only difference between 3D and 2D. So in order of finding vectors, not much has changed. Final example here, determine if the points are collinear, so they fall on the same line. So how do you determine that? So if I had a line, what's going to happen here is either situation A, which I'll do in red, P, Q, and R, either going to fall on the same line, or in green, P, Q, R, one of them is not going to be on the line. So how do we determine whether they fall on the same line? If they're collinear, if they're red, vector PQ is going to have the exact same direction as PR. Magnitude, it won't be the same, and we already talked about this. Collinear are two vectors that are on the same line. So if we can show that the direction of PQ is the same as PR, then we can prove they're collinear. How do we do that? Well, we need to find vectors PQ and PR. So start with finding vector PQ, which is just Q minus P. So 8, 1, 10 minus 2, 3, 6. Do the subtraction. Now I have a vector. So 6, -2, and 4. Then I move on and I'm going to either leave some space under that or start fresh over here. And I said PR. So I want to find vector PR, which is R minus P. So 5, 2, 8 is my R, minus P, 2, 3, 6. And I get 5 minus 2 is 3. 2 take away 3 is -1. And 8 take away 6 is 2. So how can I determine if two three-dimensional vectors are collinear? They have to have the same direction. The easiest way to do it is you find a common scalar and pull it out. So it's like common factoring. So when I look at vector Q, or vector PR, I see that there's a 3, a -1, and a 2. So if there's a 1 already in the vector, I can't reduce or factor it or divide out by anything. So that's already in lowest terms if you want to think of it that way. The other vector, vector PQ, there's no 1 in there, so what I do is I look for the lowest, or the number with the smallest number, and then what I'm looking for is the greatest common multiple I want to take out. So when I look at 6, 2, and 4, all of those I can pull a 2 out of. So I'm going to think of it as factoring it out. So if I take a 2 out, I'm left with a 3, a -1, and a 2. Now, you notice that these two vectors are the same. So they have the same direction. So what that tells me is that PQ is twice as big as PR and are on the same line. And that's because they share on the same line. Because once you take out a multiple, because they share that 3, -1, 2, they have that same direction. They have that same end coordinate. It's just PQ happens to be twice as big as PR, so it's been scaled up. So if it's collinear, they will have the same direction, and that's how you determine if they have the same direction. You take out the greatest common factor of both. In this case, we just had to do the one. Sometimes you'll have to do both in order to get it down to what we call its lowest terms. If they're the same, if you can find that match, then they are collinear. If this one would have turned out to be 3, +1, 2, then they are not collinear. They have to be identical. All right. Here's the homework for this section. If you have any trouble, you know where you're going to find me, and good luck.